This video summarizes the Math 1 lesson titled Going the Distance. This is a develop understanding task. The purpose of this lesson is for students to use the Pythagorean theorem to develop the distance formula. The performances of the Podunk High School drill team are very popular during halftime at the school's football and basketball games. When the Podunk High School drill team choreographs the dance moves that they will do on the football field, they lay out their positions on a grid like the one below. Debbie, who's standing at point D, suggests that perhaps their formation would look better to the crowd if they held their ribbons as shown in the diagram below. Notice most of the girls have moved slightly. How long will the ribbons need to be between Debbie, D, and Courtney, who's standing at point C, in the new formation? Explain your answer. So what we need to do is we need to find the length of the segment DC. And to do that, we're going to use the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. So you use the Pythagorean theorem to find the missing side of a right triangle. A and b represent the legs of the right triangle, and c represents the hypotenuse, which is the longest side of the right triangle and across from the right angle. Since we don't have a right triangle, we need to make a right triangle. To make a right triangle, we can just go from point D straight up to the x-axis and then straight over to C, so that the first segment here was vertical and the second segment was horizontal. This point I want to name my right angle just to make it a little easier to talk about. So there's where the right angle is. Let's use the letter R for right angle. So letter R. Now we can find the coordinates of point R. R has the same x coordinate as D. So since D's coordinate is 3, -4, R's x coordinate, the first one, is 3. And it has the same y coordinate as point C. C's coordinates are 5, 0. R's y value is the same since it's at the same height as point C, so R's coordinate must be 3, 0. Now that we have a point there, we have a right triangle, we can use the Pythagorean theorem to find this value of C, the hypotenuse. To get the long vertical leg, I can just count 1, 2, 3, 4 units, or I could look at my coordinates and know that the difference between 0 and -4 is 4. And here for the horizontal leg, I can count 1 unit, 2 units, or I can just look at my x coordinates and I know the difference between 5 and 3 is 2. Alright, now that I have 2 legs of the right triangle and I need the hypotenuse, all I need to do is substitute these values into the Pythagorean theorem. So I'm going to substitute 2 in for A, so I have 2 squared plus, I'll substitute 4 in for B, and that equals c squared. So 2 squared plus 4 squared equals c squared. So 4 plus 16 equals c squared. So 4 plus 16 is 20. And then to get c by itself, so I don't have c squared, I just want c. So I'm going to need to take the square root of both sides of my equation using that square root property of equality. And c is approximately 4.47. So that number has been rounded, but it's about 4.47 units long. So Gabriella notices that the calculation she is making for the length of the ribbon reminds her of math class. She says to the group, "Hey, I wonder if there's a process that we could use like what we've been doing to find the distance between any 2 points on the grid." She decides to think about it like this. I'm going to start with 2 points and draw the line between them that represents the distance that I'm looking for. Since these 2 points could be anywhere, I name them A, x sub 1, y sub 1, and B, x sub 2, y sub 2. So we need to think back to the process that we used to find the length of the ribbon and write down our steps here in terms of x sub 1, y sub 1, and x sub 2, y sub 2. So remember our steps before, we realized we were going to use the Pythagorean theorem. So we needed a right triangle. So we drew the right triangle, wrote down the Pythagorean theorem. To get the length of this vertical side of the triangle, we can just do 0 minus -4 to get 4 units long. And then to get the horizontal length here, I can just subtract 5 minus 3 to get this 2. Then once we had the lengths of the legs of the triangle, we were able to substitute them into the Pythagorean theorem and then solve the Pythagorean theorem to find the length of our hypotenuse. So let's apply those steps to this diagram. We'll start with a right triangle. So I want a completely vertical segment and then a horizontal segment. That way I can make sure that this is a right angle. So I'm going to call this point C. Now that I know that this is point C, let me go ahead and get the coordinates for it. So for point C, it's going to share an x coordinate with A. So that would be x sub 1. And then it's going to share a y coordinate with B, because it's at the same height. So that would be y sub 2. Now I want to use these coordinates to find an expression that represents the length of my vertical and horizontal segment. So here, to get the vertical segment, I'm going to subtract my y's. So that's y sub 2 minus y sub 1. Then to get the horizontal segment, I'm going to subtract the x's. X sub 2 minus x sub 1. All right, our next step was to take the Pythagorean theorem, a squared plus b squared equals c squared. For a, I'm going to substitute in the horizontal leg expression, so x sub 2 minus x sub 1 squared, and then plus y sub 2 minus y sub 1 squared, and that equals, let's call this time we're going to call it d, because we want the distance between points A and B. So this is d squared. When we were solving earlier, we could combine these because these were constants. So 2 squared plus 4 squared, we were able to take the squares and then we were able to add them together. Here, we don't have like terms, so there's nothing that we can combine. But we can get d by itself. So d is squared, so I want to do the opposite of squaring. I'm going to take the square root of both sides of the equation. So I have d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this is the distance formula. Use the process you came up with to find the distance between 2 points located far enough away from each other that using your formula from number 5 is more efficient than graphing and counting. For example, find the distance between the point negative 11.25 and 23 negative 16. Here's our formula that we came up with. When we have our points over here, we need to label them so we know what is point 1 and point 2. So let's make this point 1, so that's x sub 1, negative 11 is x sub 1, and 25 will be y sub 1, and then 23 will be x sub 2, and negative 16 would be y sub 2. So let's substitute this into our equation. Okay, now we can simplify this. So to simplify this side of the equation, we need to start with what's in the parentheses. Then we'll need to do the squares. Then we can add, and then we'll take the square root. All right, so 23 minus a negative 11. Subtracting a negative is just like adding. So 23 plus 11 is 34. So I have 34 squared plus, and then negative 16 minus 25 is negative 41, and we need to square that. So 34 squared is 1,156, and negative 41 squared is 1,681. Please be careful with negatives here. If you don't use the parentheses, then you put negative 41 squared in your calculator is very literal. It'll square the 41 first, and then it'll multiply by a negative 1 second. So your answer would end up negative, which would mean that everything from here on would be wrong. So make sure you use those parentheses, and also make sure that you think about it. A negative number squared, that's a negative times a negative. It should come out positive. If it comes out negative, then something went wrong. So these two values right here should be positive. Next step is to add them together, and that gives us 2,837. Then we'll take the square root and find that the distance is approximately 53.26 units. So now you know the distance formula and how it's related to the Pythagorean theorem. And that's it for this video. Thank you for watching.